Hey everyone, I hope you're all doing well and had a great start to your week with May 1st being today. Or if you're watching in the future, I hope you're having a great day, whatever day it is. My name is Abhinav Chede and I'm a sort of a new instructor at Brillianaire, where I'll mainly teach chemistry and some other science subjects. But in today's lesson, which is my first lesson, I'll be talking about matter and basically what you need to know about it for middle school and high school level. The first question that pops in mind, what is matter? Or what is the matter? Essentially, matter is anything that has volume or mass. But although that sounds simple, the definitions and classifications as we go along will make it a little bit more complicated. When I say something has volume and mass, you may be thinking to yourself, isn't that basically everything? Like my water bottle, my computer, my phone, literally everything has volume and mass. And my answer to that is yes, basically everything has matter because basically everything has volume and mass, but there are certain examples that do not classify as matter. So what does not matter? Matter, something that's not matter is anything that doesn't have volume and mass. I know that definition doesn't help as much, but here are some examples to demonstrate. One example is electromagnetic waves or light waves in a sense, because light, as you may know, is made out of photons or waves depending on the definition that you take. But both those definitions don't have any mass in them. So light does not qualify as matter. And gravity, on the other hand, who knows what gravity is? Scientists are still arguing what gravity is, but you can't technically. I don't think gravity occupies volume, but as of now, it doesn't occupy volume. How about that? And since it doesn't occupy volume, we can't classify as matter. But now let's dive into what different classifications of matter there are and what are the different types of matter. So, as we said earlier, mostly everything is matter, and the few examples that are not matter we're going to ignore for this presentation. And the first question you ask yourself is, can this piece of matter be physically separated? But what do I mean by when I say physically separated? Essentially, what I mean is, can you pull pieces of this piece of matter apart? So, for example, if you have a salad, you can pull the vegetables apart, and You can pull the unique parts of the salad out. For example, if you have salt water, distillation, which is essentially where you boil the liquid off, so you get the solid left. That's also a physical separation. So, if you don't know your physical separation methods, I would recommend you to study that because classifying this does depend on understanding those methods. So can it be physically separated? And if we say yes, so let's stick with the salad example. And the answer to that is yes, because we can obviously separate a salad into its unique components. Then once we answer yes, we ask the question, is the composition uniform? But what does that mean? Essentially, when I say the composition is uniform, that means is that can we visually tell the difference between different parts of the different parts of the piece of matter? So for a salad, obviously we can tell that there's different vegetables, different fruits in it. So the composition is not uniform. So we can classify a salad as a heterogeneous mixture. But what is a homogeneous mixture? That's when the composition is uniform. So let's say an example would be salt water, as I said earlier. Although we can separate it physically by distilling the water off, if we just have salt water in a beaker, we can't tell that there's two components in there, salt and water, because we would just think it's plain water. So that's what I mean when I say compositionally uniform. Can we visually tell the difference if there are two different parts, or if it just seems like it's one part? And now we trace our steps back. So we started at this question. Now we have to ask the same question, but what if the answer is no? So what if a piece of matter cannot be physically separated? And if it can't be, then we call it a pure substance. So, as I said earlier, salt water, for example, you can distill the water off. But normal, let's just say you have a normal liquid, such as liquid mercury, for example. You can't remove mercury from mercury because it's not possible. So, it can't be physically separated. So, you would claim that as a pure substance. But once you declare it as a pure substance, there's another question just like last time. Can it be chemically decomposed? And what I mean by this is, can we use chemical reactions such as combustion, burning, acid, base reactions, redox, whatever, all the reactions you learn in chemistry? Can we use any of those reactions to break this piece of matter apart? And if the answer is no, we say it's an element, such as seen in the periodic table of elements. But if we say the answer is yes to that question, that it can be chemically decomposed, then we would claim it as a compound. So, for example, you have, I don't know, you just have a piece of lithium sitting on the lab bench. And then you look at it and you say, can it be physically separated? And you remember your teacher telling you that it's just lithium. So you say, no, you can't separate lithium from lithium. Okay, then you go to the next question. Can it be chemically decomposed? So you write the formula of lithium under, and you see it's just one element. And you realize that no reaction can separate lithium from lithium, as I said earlier. So you would just say it's an element. And obviously, easier way to do this is to just look at the periodic table instead of going through this procedure. But I'm just showing you the full in-depth method that you have to go through on tests and quizzes to answer these questions. But instead of lithium, let's say you have a compound like magnesium hydroxide, or it's MgOH2. And that's a solid, a precipitate per se. And it seems like it can't be physically separated because you can't separate magnesium hydroxide from magnesium hydroxide. So the answer to the first question is still no, and it's a pure substance. But can it be chemically decomposed? And the answer is yes. Using certain reactions, we can separate magnesium hydroxide into its relative components of magnesium, and then the hydroxide will change into hydrogen or water based on the reactions. But this shows that if you chose a if you chose a piece of matter like magnesium hydroxide, it is a pure substance, but since we can chemically decompose it, it's a compound. But there's another set of chemical organisms, per se. Not organisms, but chemical compounds or elements that do not follow this set of rules, but are an exception. And those are the diatomic elements. And when I say diatomic elements, it means that in natural forms, these elements like to have a pair. So they like to stick together with their friends. So iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen, they all like to stick together with their buddies. And the natural formula would be I2, Br2, Cl2, F2, O2, N2, H2. And although you may think this is a compound because there's more than one element, and of course you can use chemical procedures, chemical reactions to split this compound into one iodine and into another iodine. And yes, certain reactions can do that, but when you go through the questions, there's a reason why they're called diatomic elements, because in this second question, you say that this element, this whatever it's called, compound element, molecule per se, cannot be chemically decomposed, and then you would call it as an element. So these are one of the tricky ones to remember on your tests and quizzes. And In my experience during my middle school and high school career with chemistry, these questions are usually the trickiest ones because you would oftentimes remember all these questions and methodology to get to your answer, but these outliers will throw you off, and then it sometimes stresses you out because you can't follow these questions for these outliers and compounds. So just remember that they're not compounds, as I said, they're elements. So, and there's an acronym to remember this too. It's called I bring clay for our new house. And there's no particular order to arrange these elements in, but this acronym, the first letter or two letters signify a diatomic element. So this is a potential method for you to remember these outliers. And now let's dive into some practice examples to test out your new knowledge about matter. So the first example here is pizza. And feel free to pause the video to go through the questions and then okay. I hope you have looked at this problem. So let's go through it together. So if we go back, can it be physically separated is the first question. And I see that I can take out the components. I can take out the cheese, I can take out the bread, I can take out the vegetables on top, the basil. So yes, I can physically separate it. And we say it's a mixture. Then we ask, is the composition uniform? Or can I visually tell the different components? Can I visually see the differences? And yes, pizza is, and this pizza shows its visually different components. So as I said earlier, you can see the basil, you can see the cheese, you can see the bread. So you would say this is a heterogeneous mixture because the composition is not uniform. Okay, example 2 now. Again, I'll give you some time to pause the video and feel free to solve it on your own. Okay, I hope you have paused the video and looked at it. Now, if we start off with the same question, can it be physically separated? This is just pure water, and last time I checked, you can't separate water from water, so it's a no that it can't be physically separated. So we claim it as a pure substance. And now we ask, can it be chemically decomposed? Water's formula is, of course, H2O, and I remember in chemistry class that there are certain reactions that can break water apart. If you remember from biology, hydrolysis reactions do this. So we can say that water is chemically decomposable, and we say it's a compound. Example 3, our favorite can of Coca-Cola. I'll let you pause on this one as well. Okay, if you have looked at it, we follow the same procedure. Can it be physically separated? Although you may think Coca-Cola is a liquid and you can't physically separate it, remember to the first example I said salt water. If you can boil the water off and you can get the salt afterwards, it's still a mixture. So Coca-Cola, of course, has sugar content, and if you can boil the water off or the solvent off, you would get the sugar content left behind. So yes, this is a piece of matter that can be physically separated. So pay attention to that because don't get distracted that it's just a liquid, so you can't separate liquid from liquid. Don't follow that misconception. Ask yourself carefully, can it be physically separated? Not just by your hands, like you can't rip it apart, but can you do the physical separation methods like distillation, filtration, gravimetric separation? All these techniques will be helpful for you to remember and understand in order to classify matter. So we said that it's a yes, and it's a composition uniform. If you look inside a Coca-Cola can, you should only see one homogeneous mixture because the liquid inside would look like should look one color and shouldn't be visually there shouldn't be any visual differences, is what I'm saying. So that means that we can say that this is a homogeneous mixture or solution because the composition is uniform, because we can't see any visual differences and it can be physically separated. And if you got a sneak peek at example 4, take take your time to pause and solve this problem. Okay, I hope you have solved it. This is actually a trick question because, as I said earlier, types of matter that are not, sorry, objects that are not classified as matter include electromagnetic waves, gravity, etc., right? And we first have to ask ourselves a different question, not this question, but we have to ask ourselves, does this object have volume and matter? Volume and mass, sorry. And rainbows, this example is a trick question because you they do not have mass because rainbows are basically a reflection or refraction of light from prisms. So it doesn't even qualify as matter, so you can't follow this procedure. So there's a trick question for you. And just on your tests and quizzes, I'm sure your teachers won't put this, but if they do, just make sure that whatever you're looking at is matter and make sure you ask if it has volume and mass. And the last example is you. Of course, I'm not asking you like Uncle Sam to dissect yourself and investigate if you are, what type of matter you are. Or example 5 is not investigating if Uncle Sam is matter, although I think history teachers would like to do that. But example 5 is a personal investigation on your own. I would like to encourage you to find one example of each of these 4 in your daily lives and try to explain why they are what they like, what type of matter they are. So for example, as I said, water is a compound because it can't be physically separated and it can be chemically decomposed. So I would like you to find your own examples in your daily lives and try to figure it out. Also, a bonus sort of extra credit if you can find another example of an object that doesn't even qualify as matter, other than electromagnetic waves and gravity or rainbows, as shown in the example. All right, guys, that's all I had for this lesson. I hope you liked it. Let me know through the Brillianaire contact process if you like this video or any suggestions to improve the videos. I'll keep continuing to make chemistry and other science videos, so if you have any questions, do keep in touch. And signing off, have a good day.